My name is Sergio Bacallado, and I'm one of the newest members of the Stats Lab in Cambridge. It's part of the Department of Pure Maths and Mathematical Statistics. And I'm a statistician. I work in the field of Bayesian analysis, which is one of the main ways of doing statistics. And the idea of Bayesian analysis is we consider the parameters in a statistical model as random variables. And their distribution represents a degree of belief or plausibility about the value of those parameters. So we have specific ways of updating this belief when we observe data. I did my undergraduate studies in the US, and I started out in chemistry, and then I did a degree in mathematics. And my PhD is actually in structural biology. I did this at Stanford University. There I was working in a computational biology group, and that's how I got started with statistics. So after I finished my PhD, I did a postdoc at Stanford as well in statistics, and that brought me here to the Stats Lab. I've always been interested in mathematics. I really enjoyed studying maths in school, and that is why I decided to study it in university. But I was always more interested in science, and especially the physical sciences, biological sciences. After doing some work in a real laboratory, I decided that it was too difficult for me and that my efforts were better spent studying the more mathematical aspects. My research is primarily on applications of Bayesian methods, and in particular what we call Bayesian non-parametric methods, which are an extension of certain Bayesian models where you have an infinite number of parameters. So the idea of Bayesian non-parametrics is to relax assumptions that we make about in specific models, so that you have a more flexible estimation procedure. I work primarily in applications, but I also do some work on developing algorithms and new techniques, new mathematical approaches to performing Bayesian inference, which is not always very simple. Bayesian analysis is particularly useful in branches of science where you have a lot of information about the mechanism of an experiment and how different sources of noise or variation arise, and it makes it very easy to combine all this information and produce not only estimates of the parameters of your model, but also to quantify the uncertainty in those estimates. So I've worked on applications in a range of areas of science. I actually started out in biology, and I worked in the field of molecular simulation. So this is the problem of molecular simulation is using computer models to understand the dynamics of molecular systems like proteins and nucleic acids. So more recently, I worked on analyzing genomic data from human microbiome projects. This is studying the bacteria that live in the body and different patterns that you can observe when you characterize the populations of bacteria in different people. But I also work in some very different areas of application. I recently started a project with a glaciologist at the University of Birmingham studying the dynamics of ice shelf collapse and trying to estimate the risk that will happen more often under different climate projections. I supervise one student in the CCIMI. His name is Sam Power, and he came to Cambridge from Oxford University, and he's working on a project around sampling algorithms in Bayesian analysis. So at the moment we're looking at a specific model in Bayesian non-parametrics, which is sometimes challenging to sample the posterior distribution, which is what we're interested in. Sam is studying a specific approach that allows you to do this exactly, but it's a costly algorithm, and so he's studying the trade-offs inherent in that method. But in general, he's interested in sampling methods in Bayesian analysis. And I think the CCIMI has been a great experience for him and for me because of the community of students and a number of activities that the Institute organizes that exposes students to contacts in industry, and allow them to talk about their research in a variety of settings, from poster presentations to short talks quite early on in the first year. And I think that's a very positive thing for a PhD student. I think the students have a very nice community. They run a very nice reading group every term, and it's nice to see the interaction of students who are all working in topics around mathematics of information. Even though they're not always obviously related, they always find a point in common.